Can you be awake and sleep at the same time? Many animals need sleep. Even birds, jellyfish enter sleep-like states where they pause less and respond more slowly to food and movement. But all of the threats and demands animals face don't just go away when it's time to doze. That's why a range of birds and mammals experience some degrees of asymmetrical sleep, with parts of their brains asleep and the other areas are more active. This is even true for humans. So, how does this work? All vertebrate brains consist of two hemispheres, the right and the left. Brain activities is usually similar across to both during a sleep, but during asymmetrical sleep, one brain hemisphere can be in deep sleep while the other is in a light sleep, and in an extreme version called unihemispheric sleep. One hemisphere may appear completely awake while the other is in deep sleep. Take bottles dolphins. Their breathing is consistently controlled by muscle surface for air every few minutes of their run. When they have a newborn calf, they must actually swim non-stop for weeks in order to keep it safe. So dolphins sleep unihemispherical with just one hemisphere at a time. This allows them to continue swimming and breathing while snoozing. Other marine mammals also need asymmetrical sleep. First field might benefit weak and non-migrating at sea. They slip into unihemispheric sleep whilst horizontally, holding their nostril above the surface, closing the upper face eyes, and keeping their dorsal face eye open. This may help them stay alert to threats from the depth. Similar pressure keeps birds partially awake. Mallard ducks sleep in groups, but some must inevitably be on the peripheries. Those ducks spend more time in unihemispheric sleep with their outer face eye open and their corresponding brain hemispheres more active. Other birds have shown to catch gene in mid-migration, while undertaking non-stop transcursive flight of up to 10 days. Breeding birds either sleep with one or both hemispheres at a time. They do so in seconds-long bursts, usually while riding air currents. But the African birds still sleep less than 8% of what they would on land, suggesting greater tolerance for sleep deprivation. It's currently unclear whether asymmetric sleep packs the same benefits as a sleep in both hemispheres and how it varies across the species. In one experiment, Farseer relies on asymmetrical sleep while being constantly stimulated. But in recovery, they showed a strong preference for sleep across both hemispheres, suggesting it was more restorative for them. Dolphins, on the other hand, have been observed to maintain high level of alertness for at least 5 days. By switching which hemisphere is awake, they can several hours of deep sleep in each hemisphere throughout the 24 hours period. This may be why a unihemispheric sleep alone meets their needs. So, what about humans? Have you ever woken up growing after your first night in the new place? Part of your brain might spend the night only somewhat asleep. For decades, scientists have recognized that participants sleep poorly their first night in the lab. It actually constantly to cause out the night data. In 2016, scientists discovered that it's the first night effect that is very subtle version of asymmetrical sleep in humans. They saw that during the first night, participants experienced deeper sleep in their right hemisphere and lighter sleep in their left. When exposed to infrequent sound, the lighter sleep left hemisphere showed greater bumps in activity. Participants also woke up and respond to infrequent sounds faster during the first night when they experienced deep sleep in both hemispheres during the night follows. This suggests that, like other animals, humans use asymmetrical sleep for vigilance, specifically in unfamiliar environments. So, while your hotel room is obviously not trying to eat you, And you're not going to die if you don't continue moving. Your brain is still keeping you alert, just in case. One more. Many animals need sleep. Even brain jellyfish enter sleep-like states where they pulse less and respond more slowly to food and movement. But all of the threats and demands an animal's face don't just go away when it's time to doze. That's why a range of birds and mammals experience some degree of asymmetrical sleep, where parts of their brains are asleep and the other areas are more active. This is even true for humans. So, how does this work? All vertebrates' brains consist of two hemispheres, the right and left. Brain activity is usually similar across both during sleep, but during asymmetrical sleep, one brain hemisphere can be in deep sleep, while the other in its lighter sleep. And in a extreme version called unihemispheric sleep, one hemisphere may appear completely awake while the other is in deep sleep. Take bottle-snub dolphin that breathing is consequently breathing by the surface for air every few minutes where they are drowned. When they have a newborn calf, they must actually swim non-stop for weeks in order to keep it safe. So, dolphins sleep and unihemispheric with just one hemisphere at a time. This allows them to continue swimming and breathing while snoozing. Other marine mammals also need asymmetrical sleep. First seal might spend a week on land migrating at sea. They slip into unihemispheric sleep while floating horizontally, holding their nostril above the surface, causing the upper face eyes and keeping the down-facing eye open. This may help them stay alert to threat from the depth. Similar pressure keeps birds partially awake. Male ducks sleep in groups, but some must inevitably be on a periphery. Those ducks spend more time to unihemispheric sleep with the outward-facing eyes open and the corresponding brain hemisphere more active. Other birds have shown to catch these in mid-migration, while undertaking non-stop transmit flight to up to 10 days. Frequent birds either sleep with one or both hemispheres at a time. They do so in second-long bursts, usually while riding air currents. But the frequent birds still sleep less than 8% of what they would inland, suggesting greater tolerance for sleep deprivation. It's currently unclear whether asymmetric sleep packs the same benefits as sleep in both hemispheres and how it varies across the species. In one experiment, birds' ears relied on asymmetrical sleep while being constantly stimulated. But in recovery, they showed a strong preference to work across both hemispheres, suggesting it was more restorative for them. Dolphins, on the other hand, had observed to maintain high levels of alertness for at least 5 days. By switching which hemisphere is awake, they get several hours of deep sleep in each hemisphere throughout the 24 hours period. This may be why unihemispheric sleep alone meets their needs. So, what about humans? Have you ever woken up to groggy after your first night in a new place? Part of your brain might have spent the night only somewhat asleep. For decades, scientists have recognized the participants sleep poorly their first night in the lab. It's actually customary to toss out the night's data. In 2016, scientists discovered that its first night effect is a very subtle version of asymmetrical sleep in humans. I saw that during the first night, participants experienced a deeper sleep in their right hemisphere and a lighter sleep in the left. When exposed to infrequent sounds, the lighter sleep in the left hemisphere showed great bumps in activity. Participants also woke up and responded to infrequent sound faster during the first night than when experienced deep sleep in both hemispheres during the night following. This suggests that, like other animals, humans use asymmetrical sleep for vision, specifically in an unfamiliar environment. So, while your hotel room is obviously not trying to eat you, and you're not going to die if you don't continue moving, your brain is still keeping you alert, just in case.